All right, everybody, we're back. And we are going to go and finish parts B and C here. Now, the nice thing about organic chemistry is they tell you what order the carbons are in and what's attached to each carbon. Now, you know, these H's aren't between two carbons. You know that, right? Even though they're listed there. Hydrogen makes how many bonds ever? One. So you got a C on the end with how many H's sticking off the end? 3. So you start by doing that. Notice, didn't even count the valence electrons. Don't have to. So that's the CH3. Then look to the right. There's a C, correct? Does it have any H's on it? No. What's after that to the right? A C with no H's on it. What's after that to the right? Notice I'm not worrying about filling octets yet. But this next C, the fourth C in, has 2 H's, right? Put them on there. I don't care up, down, left, right. Just don't put them in between 2 atoms because H doesn't do that. Ever. H makes 1 bond maximum. Don't put lone pairs on H either, right? Don't do that. Okay, the next over is a nitrogen. With how many H's? 1. And what else? A C. It's the one on the left, yeah? Yeah. And you're not done. All you need to do now is go back to the nature of atoms and make sure every atom obeys. This carbon obeys. It's got four bonds and no lone pairs. This carbon does not obey. It needs 4 bonds. It has 2. You're allowed to add 2 more bonds and that's it. Do not add lone pairs. It will be wrong. Carbon does not have lone pairs. Okay? So we are going to draw 2 more bonds because we need 2 more bonds. They got to be to the next carbon, don't they? There's no other. You can't go to the left. Try it. Uh-oh. Uh-oh. Don't write that down. It's wrong. How do you know? Yes. The carbon on the left has 5 bonds. On your test, here's what happens. I write the 2 letters OV, standing for octet violation. And the score you always receive, -1 point. Okay? All right. So we don't want to lose a point for every octet violation. Do not put that red line there. There's the second bond. Carbon still has only 6 electrons around it. It needs a 3rd bond. That combination is a triple bond, right? A little preview. Preview. 1 sigma 2 pi. Pi. 2 pi p. No. You'll learn that pi's come from p. What does that mean? 1 sigma bond. So you want to read about those things before Wednesday, okay? And we're almost done. What's the only part that's not done? Nitrogen. Nitrogen. Yeah, before I move over there, this carbon's happy too, right? 4 sigmas, 4 sigmas. Nitrogen's nature is to have 3 bonds. And how many lone pairs? 1, put on that lone pair. And then done. Congratulations. Do you want to just this one time verify we have the right number of valence electrons? Yes, come on. I know you trusted me. You trust me. You don't have to count the valence electrons. But you know, for those who don't trust me. Oh. Where's the line? I'm getting better. Okay. All right. on the video. Okay, next one over. Next one over. Hey, they've got the skeleton for that ring for you drawn out. That was empty.
What does it?
Oh, I'll tell you what that means. There's a package of math around somewhere. Please. Yeah, pass it to Forbes, please. What this means here is there's this ring with 6 carbons in it. Oh, and there's stick figures here. So that's a preview for us. Whenever 2 sticks meet on an angle, there's a carbon where they meet. So let's do the easy part. It does. It's a whole new language. So I'm just redrawing those sticks like this. So corners, when you see sticks like that, corner is a carbon atom. It's understood. And I'm going to put those, hey, what bonds are missing? I've drawn the first bond between each carbon. Instead of saying the double bond, because that doesn't answer my question, which bond is missing based on this fact that here, the first bond had a special name, and the other 2 were called pi. That's right. So these are missing the pi's. I'm going to put the pi's back on because, you know, they didn't disappear. So that is the longer form of the ring portion. And you're learning something else about stick figures. Those carbons all have octet violations, right? Yeah. But stick figures, it's understood. There's no charges listed, right? Do you see charges up there? It's understood that you're allowed to omit hydrogens that are bonded to carbon. That's all you're allowed to omit. But you understand that they are there to fill the octets of those carbons. On each of those top, starting from the top, because I do see a bond on the picture there and there, right? So there's no hydrogens there or there. But all the other 4 carbons each have a hydrogen. So yeah, it's new language. We got to learn it. Stick figures 101. There you go. It's understood. To get full octets from the stick figures, you fill in with H's, unless you're told otherwise, which we are here and here. We're told those are carbons, right? Now, oh no, we aren't told that's a carbon to the right, are we? My goodness, I can't read. That's not a carbon. That's an oxygen. In fact, let's get, come on. Wow, that was close. Go green. Right there. O. All right, what's attached to that O? The green O. Another carbon. And how many hydrogens are on that carbon?
1.
1. It sticks off, right? And then there's a carbon after that, right? With how many hydrogens on that?
2.
2. Hey, what's carbon's nature? Because you can't put any more atoms on there. Yeah, say it a different way. You've already got one of the bonds. What's the second one? Pi. I'm just trying to get you to talk the right way. It's looking ahead, so you're not used to it. But yeah, after you've done the sigma, the next bond is always pi. There's only room for one sigma, ever. Remember that. There's only room for one sigma between 2 atoms. And it is the best bond, so it happens first. When I say best, I mean most stable. And we have a double bond, like somebody said, but really that new one that I added was just the high portion of the double bond, right?
Does it have double bond?
Yes. Now, CO2H is a pattern that's very common in organic chemistry. That's why I'm bringing it up right now. Because it's very common. It's in like 3 functional groups. When a CO2 followed by an H, we call it a carboxylic acid. It's brand new. It has a double bond to one of those oxygens. Yeah, only one of those oxygens. Doesn't matter. You can do this, and you can't You can't bond the H to the C. It has to be bonded to an O.
Does any of the O's keep the lone pair?
You know O's nature. We're going to finish all the O's lone pairs, like right now. Now that carbon is not full yet. And how does carbon always get full? You're not allowed to add hydrogens. You got your C, you got your two O's and your H. You're not allowed to add any more atoms now, because look, C with two O's and an H.
So double bond.
I need, okay, but what about this story here? Yeah, double bond. Yeah, that is the story I want. I'm sorry, I forgot the question. I need a double bond. Which one's better? This one
The one that doesn't
or this one? He was correct for reasons that aren't obvious, but it's going to be formal charges. I'll do the proper one, and then I'll do the other one underneath, and you'll say why it's not as good. Now, oxygen's nature. We got the bonding part of oxygen's nature done for each one, right? Two bonds to oxygen. How does oxygen always fill its octet after that? Two lone pairs.
That was my question.
And there's our answer. See? Winner, winner. Sorry, the oxygen on top.
So carbon.
Oh, it doesn't matter left or right.
No.
Oh, yeah, we didn't finish the nature of oxygen on top before I moved back to the,
So carbon never is lone pair.
never. Yeah, use that table we did on the previous page. Must obey that table. Doesn't obey that table, you're losing points. Oxygen on top, let's finish it off. Two lone pairs. Uno, dos. Oh, it's out of time. Oh, so sad. Okay. And the other alternative here, I'll do the C from the ring there. And the alternative I mentioned that isn't as good is here. And it would have done this. And the reason I don't like it is there and there. Which one of those is better? We're talking about this C, this one versus this one. The one on top's better for an obvious reason. What is it? No formal charges. It's more stable than formal charges. So do yourself a big favor. Every time you see CO2H, you're going to draw one of the C's double bonded to, the C double bonded to an O. And then also on the same C, OH. And I don't care if the double bond one is on top or to the right. It doesn't matter. You can rotate things in organic chemistry. We're going to learn, and we're doing that all the time. So I had more activities ready, but nice slow start the first day. I'm going to stop our video, and I'm going to collect those from you.